So yeah, today I'm going to praise Maxon. There you go. And I'm going to show you some stuff as usual, which you may not know. I'm going to talk about this and a few other things. So a bit of a backtrack. I'm one of the privileged people that has a personal relationship with most of the Maxon guys. Not everyone likes me, but that's a good thing. If everyone likes you, there's something terribly wrong with how you behave. Okay, we need to understand that. So I've got this good balance. Anyway, back to Maxon. So meeting the geeks that create this software, because I'm going to talk about the developers at Maxon, we would assume that these are people wired with a USB cable sitting on their computers, like typing, when they communicate with each other like that, binary format. But actually, these people play music. They actually play real instruments like guitars and drums and basses, and they actually sing I think by percentage amount of artists, musical artists, within a tech company, Maxon is by far the highest margin. They read books. They have real lives. They have families. They go out. They enjoy themselves. And for some funny reason, they do very good work. And they have time to create projects for free. So that's a weird thing. I never figured that out with a 24-hour thing. I can't do anything in 24 hours. Anyway, so Maxon, a few months ago, released this new website called labs.maxon.net. And if you are visually challenged like me, let me show you that. So labs.maxon.net, okay? And if you wiggle the cursor, it becomes even bigger. There you go. So on this website, Maxon developers, on their spare time, which means it's very cheap for Maxon, they develop their own little plugins, and they offer them to anyone for free. Now, at this point, there are only 5 of these plugins available, and I'm going to show you 3 of them because they're quite interesting. And the best part of it is that these are open source. So the Py-Parametric tools, which were created by my very good friend Andreas Bloch, and the extrudifier, which was created, I think, by Ed Bidoff, and Ricardo created the Kuhns mesh, Ricardo Gigante. And this one and this one are open source. I'm not sure about this one, which means that if you're a coder or have an interest in doing any kind of Python scripting or coding inside Cinema 4D, you can take the code, pretty much copy-paste it, and call the plugin your own, okay? So I'm going to talk about a few other things later on, but let's begin. Let me show you what these free plugins do. You just go read more, and then you download it, and you put it in your plugins folder, and if the internet works, which it does, you install it. So let me just create a new scene, put on my bionic vision glasses, and show you what the Py-Parametric tools do. So I'm proud to say that this project was my idea. So I had a discussion with Andreas Bloch. He's in charge of the SDK team and SDK support at Maxon. So if you go to the appropriate website, developers.maxon.net, Andreas and a few other extremely good coders will show you anything you need to know about coding and solve your problems. Anyway, so what do we have here? Let me right-click on the icons and change the icon size, just to see them better. What you will see here, if you've been using Cinema 4D, is some of the names. Let's go to this menu here. Where is my, oh no, yeah, there you go. So extrude inner, smooth shift. What you will see is a lot of these tools have the same names. So extrude inner, extrude, and they have 2 versions, the blue ones and the green ones. The blue ones are deformers, and the green ones are generators. Just like we have generators, which are green, and deformers, which are blue. And basically, it's exactly the tools you'll find in your modeling toolset, but in a live procedural state. So let me show you a few things, what you can do with these things. And I'm going to use my favorite primitive, which is the cube. And I'm going to use a pi extrude inner. I'm going to turn on my lines. And you can see that immediately we have an inner extrude. It's exactly the same, just to make sure you understand what's going on here. If I take a cube, make it editable by clicking on this or pressing C, then going to polygon mode, then selecting everything, then pressing I for the inner extrude, clicking and dragging, it's exactly what this does, the same functionality. But it's in a procedural state, which means that while it's a deformer, we can go and change things like the offset and the variation and create n-gons and so forth. Now, what's great about this is that it's non-destructive, so you can change it at any time, and you can stack them up. So let's see what this is all about. I can go and say a Pi-extrude modifier and put it after this one, and do this. Now, of course, you're going to start asking, yeah, but what if I just want to extrude these ones, not those ones? Well, the way the tool has been implemented allows us to do a hack. And this hack uses the correction deformer. Now, anyone that doesn't know, the correction deformer was originally developed for character animators to do what's called a correctional pose. So because when we have a model created and it's being deformed by joints, the way that object is created means that we cannot go and move points around because the whole system is going to fall apart. What the correction deformer does, and because correction deformer put it as a child, I'm going to turn this one off, is that although our original object is a procedural object, it's a procedural cube, the correction deformer allows us to make selections within a procedurally set up object. Whether this is generated by a generator, whether it's created by using one of our Pi modeling tools. So what I've done, not on the cube, but on the correction deformer, I've selected these four sides. And it works normally like any polygonal object. If you have your correction deformer selected and polygon mode, you can go and select any points, polygons that you want. And we will assign a selection, a polygon selection on the correction deformer that represents these polygons. And I'll call it selection 1. 1. There you go. And I'm going to go to my extrude modifier and drag this in here. So what we have here is a procedural cube, a procedural inner extrude, then a procedural polygon selection, then a procedural extrusion modifier. So what we can do now is continue exactly like this and go further down the line. And then I'll say, OK, I want another correction deformer. I'm going to delete these ones, put it under here, go with my polygon selection tool and select the top one and the bottom one only, and create another selection here. So set selection. And then I'm going to create another extrusion modifier. I'm just making copies. Delete this, drag this in here. So now I can extrude that. Maybe I want to do an inner extrude. I'm going to grab it from here this time. An inner extrude on these polygons and do that. And the other one, as you can see, stays procedural. And although I am modeling now, I can go and change any one of the parameters of the stack you see here. So some people object to this because when you have too many of these modifiers, let's call them, these real-time calculations, your scene may start getting slower if you have a lot of polygons. But nothing stops you from, when you're happy enough with the whole scene, right-clicking and saying current state to object, and let's delete these two, grab the cube, put it in a new scene, and we have a frozen state of that. And then you can continue doing stuff. So number one, for prototyping, for quick iterations, when you're not sure exactly what you want to do, which is something that happens to me all the time, you can use this workflow. And funny enough, if you go to the plugins folder, so show in Finder, go to plugins, somewhere around here. And you go Py-Parametric tools. And basically, I think we can drag this in a text edit. And that's your Python code. So basically, it's open source. You can learn how you did this. It's very well documented. And if you don't understand something, you can always contact Andreas and his team and ask him about details. Now, I'm going to revisit this because there's one unique thing you can do. Actually, I'm going to show you right now. So in Cinema 4D, we have a few ways of creating thickness. We can use the cloth object, we can use the explosion effects, we can use the Voronoi fracture, different ways. And each one has its advantages and disadvantages. But by using the Py-Extrude modifier, it's much more simple. And I'm going to show you a nice little trick, because when I was back in the UK, this is status, by the way, the thing I'm doing. So when I was back in the UK, I was doing a lot of packaging for the tobacco industry. And all the modern packs have those weird folds and all that. The problem animating a pack, opening or closing, if you want to do something fancy, is that if you create the thickness and then you want to rig it so it opens and closes, it's very difficult to rig because when you add thickness, you double the amount of points, and you have to take all these things into consideration if you're using joints. So the ideal solution would be a quick modifier to create extrusions. And I'm going to show you a very quick example how to achieve that. So I'm going to create a plane with just 3 segments and turn on my lines here. I'm going to just close this. So here we have this nice little plane. I'm going to press C to make it editable. And the next thing I'm going to do is go to my character menu, get the join tool, and go and activate my snapping. And then I'm going to click here, click here, click here, and click here. And I've created these 4 joints, which are right on those points. Take them out of the hierarchy, select everything, deselect the null. I need the joints and the object. And go to the character menu and go to commands and do a bind. So what this will do is create a skin deformer. The skin deformer links the joins to the mesh using this little bugger up here. Anyway, I'm going to press R to rotate. You can see that this folds now nicely. Great. And I'm going to create a very quick espresso. Now, a lot of people are afraid of espresso, but they shouldn't. I'm just going to go here, and I think, yeah, my rotation is the P. I'm going to right-click on the P, go here and say Set Driver, go on this little bugger, right-click and say Set Driven. And now, whenever I rotate this, the other one rotates as well and creates this kind of closing finger. So how is that about espresso? It's not that difficult. So let's make this 15, so I have nice creases. There you go. And what I'm going to do is at frame 0, I'm going to set a keyframe here. I'm going to go frame 90, set a keyframe here, go to frame 45, rotate this, set a keyframe. So now I can just scrub around and look at what happens. OK, let's go and add some thickness. Go to the plane, go to plugins, Py-Parametric tools, Py-Extrude modifier, drag it underneath, and we have thickness. We don't have a cap. As you can see, it's open. By default, our extrude tool does not add caps, so you need to create caps. That's nice, but we all know that nothing is as sharp as what a default 3D cube is. So let's go and add some rounding. I'm going to go in my Py-Extrude modifier and add some subdivision. I'm just going to add 2 subdivisions. So now I have this middle row of polygons. I want to push that out a bit. I want to create a little bit of a rounding over there. And that's a very simple thing to do with this workflow. I'm going to use a correction deformer, drag it here, go to polygon mode. Let's turn off our snapping for good measure. Press UL, which is loop selection. This will select all the loop around, as you can see, all the loop. And I'm going to set my selection, call it loop, and then just add a, I think it's the normal move. Where is it? Reverse normal move modifier. There you go. Drag the selection in, and it only moves that selection. make it 1 or 2. And now we have this rounded thing. You can add more polygons, and it has a bit more substance to it. The good thing about this is because of the modification, the thickness and the rounding is applied after the folding, then the model is always correct. Now, one thing you need to understand that all these methods have certain limitations. In the current state, if I go to my Pi-Extrude modifier, let's zoom in here to see what happens, and increase the number of subdivisions, then you can see that that loop is lost. Don't forget that this selection here is a fixed selection. So all you have to do is go to the correction deformer, go and select, let's add one more subdivision. No, that's not it. This is it. So go to your correction, go to your loop tool, select this, for example, or this, and this, and this. And with this selected, just say set selection, and that is it. So you will need to do some changes. And then I can add another one and extrude the other one a bit more, and so on and so forth. So it's a free tool. It's ideal for adding thickness or creating procedural 3D prototype modeling by using all your well-known tools, plus the fact that you can look at the code and add any of the other tools, because Andreas did this with like 1, 2, 3, 4, 5, 6, 7. Some of these don't really make sense in the sense that you can do the same thing using a dedicated Cinema 4D tool. That's why this is just an exercise you can take advantage of. But at the same time, if you're in coding and you want to learn coding, it's a very good source to learn how these are made and how to add more modeling tools as deformers or as generators. So this is the first part. Did you enjoy it, I guess? Did you like it? Yeah? Yeah, you're all my friends, so you'll say that anyway. Okay, so let's move to sorry, something else. And let's go and check. Let's close this and that. And let's go and see. Let's check out the Coons mesh. Now, this is an interesting one. So plugins, Coons mesh. So Coons mesh, again, it's a prototype of a tool which allows you to do spline modeling, like NURBS modeling. And although it's not fully featured, it's a fully featured quad Coons mesh tool. Let me show you what it does. So I'm going to go to my top view. I'm going to get my pen tool. I'm going to create spline, press escape twice, and then what I'm going to do is turn on my snapping, press command to create a new spline, then double escape to go out of the tool, press command again. You can see I'm using different numbers of points on purpose. Double escape, and then command, and I think that's it. So I have these 4 splines, which the beginnings and the ends of each one coincide. What the Coons mesh allows us to do, and let me see if they're in order. They are in order. I'm going to grab them all, make them children of the Coons mesh. And automatically, this gives us a mesh. And by changing the topology of any of the splines, the Coons mesh complies. Now, it has a second way of applying these splines, and that is through these little links here. Now, the reason you would use the links is that you can use one spline in more than one Coons meshes. So if you want to do that and create a more complex object and use the common edges in more than one Coons mesh, then you would just go and drag them and drop them in the links over here. But for now, we're going to leave them as they are. So we can change the number of steps, and this is one of the great things. We can change the subdivision in any of the 2 directions. And it retains its procedural nature. There is an example here made by our own Glenn Johnson, one of the best 3D modelers I've ever met in my life, and I've met a few. And Coons mesh, I think this is it. Yeah. So this is just part of a model he started creating just as a sample here. Now, I have to be very honest with you. This is not a full NURBS modeling tool, okay? And it needs a lot of work. But for some very specific types of models, it caters, it helps you create these models much easier than with standard ways. And both the sample, I think, and the plugin are available for free on Maxon Labs. So I suggest you go download it and just play around with it, read the instructions. And yeah, if you make anything nice, post it. And let's move on and see what else we can do. Oh, by the way, I'm under the impression that we can use these in conjunction with the other tools. I may break it, but who cares? So let's get an extrude modifier, and let's create a null. And because it's a deformer, I can apply it this way. Oh, yeah, it works. Why wouldn't it? Why wouldn't it? OK? And again, we can use the same things with correction deformer and all that. So this is now a nice, thick, whatever this is. Excellent. So let's move to the next one, which is, let's go back here, the extrudifier. So I think I have a scene with the extrudifier here. And I'm actually going to just grab this guy here, copy and paste it. So the extrudifier is a Python generator. A Python generator, if you don't know, it's an object somewhere in here, Python generator, where by default it creates a cube. It does everything using code. So these two lines, and basically this return C4D base object, C4D O cube, just creates a standard cube. Okay? But if you write the appropriate code in there, which I have no idea how we do that, it can do interesting things. So in this case, I'm going to add a cube and make it a child because it's a generator. And basically, it's a greebling generator. For anyone that doesn't know the terminology, a greeble is just a semi-randomly created object where you get random extrusions and inner extrusions to create like cityscapes and stuff like that. So this is just a cube, and I'm just going to make the cube invisible because it doesn't make it invisible by itself. If you want to see the code and learn how this is done, just go and read this. Obviously, yeah, that's how I would do it. And it has some user data, and the user data is quite simple, how many levels it will have for extrusion and so forth. So you can see the more we change these numbers, these random extrusions change, the seed changes, the randomization, how many levels, how much depth these have. You can see you can create some really interesting things with this, okay? So let me show you. I'm going to combine this with mograph, which is something I promised yesterday, and show you what you can do with this. So these are attributes. And as I've told you previously, mograph can blend between attributes of same types of objects. So I'm going to have extrudifier 1 and extrudifier 2.2. And I'm going to change the seed and make it 100. So everything else is the same except for the seed value. And seeds are just numbers. So when you see any kind of randomization with noises or any kind of randomness, the seed is just the base number where the calculation begins. If you have a seed number of 0 and seed number of 1, there is no, you can't tell you can't predict the outcome if the numbers were 0 and 1,000. So every number just gives you a different randomization. So if I take these two little buggers and take a mograph cloner and stick them as children of the cloner, and let's distance these things a bit. And I'm going to put it in blend mode. Each one of these things is going to be different. There you go. So just different. And let's see if we can do something interesting here. If we can put it in a radial configuration, do that, increase some of these things. Instant bad person spaceship. You know, this is a space station of the villains. And that's just by using our greebler, the extrudifier, and a bit of mograph. You know, and it's procedural. And let's go and do something interesting. So I'm going to make a copy of this guy using my command and click, I'm going to create a light, put it underneath here, make the light a square spot. And let's go to our transform and turn this, there you go, minus 90. And what else am I going to do? I am going to select the light, not a square spot, but a parallel spot. That's parallel spot. Yeah. So then I'm going to make that spotlight visible. Render this, there you go. Getting interesting. I'm going to make this light a bit thinner and go to visibility, push this in here. Not bad. Then I'm going to take another light, make it visible. So yeah, I'm going to make this visible. Nice. Make it a bit bigger. Make it a bit greener. Bad lights are always green, aren't they? So make it nice and green. Good. Then make one more light. Make it volumetric. Make it large. There you go. And we have an instant kind of spaceshipy thingy with the lights shining in the middle. I'm pretty sure you'll find a way to use this in one of your next sci-fi projects. But this is a type of stuff you can do to, prototype ideas and so forth. And it's just a result of some random Maxon developer sitting down and saying, oh, why don't I write this in Python? So use the extrudifier. It's not a plugin. You will not find it here. It's just you find it in a Cinema 4D file. Go and investigate the code. There you go. Investigate the code. Find out how it works. And, enjoy it. So I've pretty much run out of material here. I thought this will happen. So I think I'm going to show a bit more of mograph and stuff like that. Or if I look at my files, I will find something I haven't shown yet. Oh, yeah. I haven't run out of material. So we're going to take a sidestep. Now, who's heard of Cineversity? Okay. Cineversity is the repository of Cinema 4D content and tutorials, which is curated by Maxon US. And if you're an MSA subscriber, is it? Yeah, it's a subscription. Yeah, MSA. If you're an owner of an MSA, you have access to it. If you don't, ask someone there in Maxon; they'll tell you. Now, one of the things we do on Cineversity, I have many tutorials there, so go and watch them. Is we create plugins, workflow plugins that help people out. And again, my very good friend Donovan Keith, which is one of the smartest guys I know. I think he's too smart. And I had an idea about how can we create procedural selections. So we do know, we do know that when we create any polygonal object, make it editable, I can go and create selections. Now, what a selection tag is, it's nothing more than a list of numbers that relate to which polygon is selected. So each mesh object has its polygons named from 0 to whatever. So 0, 1, 2, 3, 4, 5, 6 for 5 for a cube. 0 to 5, 6 sides. And I think if we go to the structure and go to the mode polygons, these are the 6 polygons, and you can see which one is selected. So if you ever want to see the structure of how a mesh, what's a mesh made of, you can go to the structure manager, change the mode, and it has quite a few interesting things, like UVs, vertex maps, n-gons, and so forth. It's very, very helpful. So if we take, number 2, this is polygon number 2. This is polygon number 1. This is polygon number 4. These numbers are stored in this little tag inside. The problem with this is that you cannot directly add this little tag to a non-mesh object. Now, there are a few hacks you can do. So this is the polygon that's saved in this selection. If I make a procedural cube, drag this on this, delete this, make a material, make the material red, or green for that matter, drag it here, and put this in here, you will see that the selection is retained. Because as far as Cinema 4D is concerned, that is just one number in there. Whether I put this selection tag on a sphere or a cube or anywhere else, there will always be one polygon which has the red color, because that's what the tag tells it. So in theory, there should be a way for us to create these kind of selection tags for any type of object, not only based on a selection, but based on some sort of code. And because I didn't have any idea where to begin, but I'm quite convincing, I got both Donovan Keith and Andreas Bloch working on it. And they both did a tremendous job, much more than I asked for, which made me feel a bit bad. I'm joking, I never feel bad. Serves them right. And what they did was the following thing. Let's go to our parametric selection tag. Let's I'm going to, do it here. Copy, new scene, just a new scene. Get rid of this. And what Donovan did, he created this Python tag. It's similar to the Python generator, but it's applied as a tag. And again, the fantastic thing is that the code is open. Okay, there's a lot of it, but a lot of it is just to keep things in order. And you know, it's well commented. So if you're encoding and all that, you can go read through the code and learn how it's done. What this does is the following. Let me just delete this, go here. If you go to the main attributes of this tag, you will see that it has different modes of generating polygon selection. By borders, circumference, facing normals. I mean, this is fantastic. So anyway, what you do is you go down here and you create a new selection tag. So anything now we select in here is going to feed this selection tag with the appropriate information. I'm going to go to this material, put this in here, so to make sure that we see the selections in red. So currently there's nothing selected. So watch this, facing. And just so that we know what we're looking at, I'm just going to add the lines. When you activate any of these, you get a tab here. What it says is it's going to select all the polygons which comply to the following rule. They are facing towards the positive y, that's a vector, and have a tolerance from that 15 degrees. This is exactly like Houdini's selection by range. So what we did here basically is try and use Python code to emulate one of those things. So by changing the tolerance, we change the polygon selection. We can change which way the vector is pointing, and opposite to get a symmetrical selection. And because it's a selection now, we can go and use them using the parametric tools. So let's go and do a extrude modifier, drag it here, drop it here, and do this. There you go. And this now, let's go and start changing these parameters. So we can add different types. So let's add a noise. Let's go to the noise and say, let's change the bias. We've got animation speed, which means it's animated, it moves around. I can change the scaling of the noise, make it smaller or larger. I don't want the noise, so turn it off. I want to select by polygon circumference or their borders or a bounding box. So I want to select bounds. All the polygons which are from 0 to 100% of the bounding box of my sphere, and let me just do this, and let me just turn off the facing for now. 25% of the height, so only a quarter of my sphere, and 100% of my depth. Maybe I don't want this whole thing. Maybe I want more of it. So bounds. Then you can select based on distances, based on indices. And Donovan has created a sort of a language. This is a legend for you. If you just type numbers, it will just go and select the polygons with the appropriate numbers. So I want polygon 1. And polygon 1 is somewhere there. That's polygon 1. Or polygon 0. I want 0, 12, 34 to 59. So it's selecting all these. So you can go by number and select anything. Then it's got deselect. You can add these things here as a string, so you can do all these weird selections. Let's move on. A pattern. Have different patterns. And the pattern now is X and minus, which means select one, don't select one. From 1 to -2. It's, you know, the ways you can select polygons is fantastic. Random. Polygon type. Triangles, quads, n-gons. So you can use it as a utility to troubleshoot your mesh if you're looking for n-gons to triangulate them, or triangles if you want a quad mesh to go and fix it, and so forth. Then we have post effects. You can create symmetry. We can create select planar polygons. We can grow and shrink our selections and all that. And we can go and add more of these selections and add them or subtract them and do all sorts of other fancy things. I think he has a proximity as well, which I like very much. Distance. Go to distance. Let's get a null. And let's go here and drag the null in here. And distance 150. Yeah, I have to drag this one. There you go. So now, any polygon that's within a range, a distance range of this null is going to be selected, or any other object. So you can start creating other types of effects. So you can use this on many objects. When they come to a certain proximity, there's a selection, something happens, an extrusion, or a color change, or something like that. And we're still working on a procedural object, by the way, which can be anything, a generator, it can be anything we want. So, yeah, so if you're members of Cineversity, this is not the only plugin. Cineversity has, I think, 20 plugins, workflow plugins, which are fantastic, including ArtSmart, which allows you to open up Illustrator files with layers and colors and all that and work more efficiently than the traditional method, and so forth. And if you need to learn more about Cineversity and the MSA and all that, go and talk to the rest of the Maxon people, because it's my opinion that if you are a Cinema 4D user and you're using it to make a living, you do need to invest the MSA amount every year, because it will keep you up to date. The content, I mean, my tutorials alone are worth the MSA. You know, let's keep it simple. And yes, go and talk to Maxon about this. So this is the Py-Parametric tools, which you can use in conjunction with, the Pi selection tools. You can use them in conjunction with Py-Parametric tools, and so forth. So we are 40 minutes in, and we saw the extrudifier. What else did we see? So what questions? Any questions? Any questions? Any questions in general? Any question? Any questions? And Andres? Oh, yes.
How to make a knot?
A knot?
Yes.
I think there's a plugin that makes knots. Now, I don't think you can, well, I would create it manually. I'll get a spline and do. Now, there are certain knots which are based on mathematical formulas. Okay? I do not know that math, but if you know the math, then you can pretty much use a Python generator or something like that. What's the aspect of knots? Just in case the question was, how do we create knots in Cinema 4D? What's the difficulty for you? Is it the difficulty?
Spline, not to interact. Drawing a spline into a knot is the first complex thing. But then not to interact the spline.
Okay. So it's the interaction, basically. That's unfortunately, that is not a simple solution for any software, because if you want a knot to be realistic, you need to have some sort of elasticity between those things. And that is, if you want to make it static, well, you can go and edit stuff around with, Deformer or something like that, or edit your mesh. But if you want that to be procedural, then you go in a very complex setup that may involve cloth simulation. It may involve all sorts of other things. But there's no one answer about knots. It all depends on what knot you're trying to do, if it's animated or not, and how much time you have, and all that. Other questions? Question? No? Well, let me see if I can spend another 10 minutes showing something. Andres, what do you think? What would you like to see? Do that. What do you want me to show?
Very complex.
Very complex stuff. Yeah. Show something very complex. No, I'm not. No, I'm not. So let me see if I can show you a couple of things, because my first presentation 2 days ago was about mograph, and there's always more things to show about mograph. So let me show you a few things. So yesterday, at the end of my presentation, I mentioned how to bring random objects into the mograph context using the fracture object, okay? And I'm going to show you something else. There's a really nice, very powerful object in mograph, which I have no idea what half of it does. I can use it to a certain point, which is the spline. Now, the spline is the generator that either generates splines procedurally or brings splines in the mograph context. So when you generate a spline, it has a simple mode. It has things called turtles, which is this weird language based on A, Bs, and whatnot. This is actually a code that creates trees, and these trees are animated, and you can do all these things. This is the default behavior. So if you want to impress your friends, just press one button and do this and be like, I made a tree. Now, but the mode I use is not the turtle mode. It's the spline mode. I'll tell you why. I'm going to make a flower, and I'm going to go to the spline, drag the flower. When you activate the spline mode, you go to spline, and you drag this in here. Okay? And I want the mode, if you put it on vertex mode, then it will copy the structure of the other spline. Every vertex is going to be the same. I'm going to put this in even mode. And what this allows me to do, it allows me to resample my spline. So regardless of how you make a spline, you can put it through a spline object and resample it. And now it's got equal distances all around. Not only that, if I take a sweep object and a circle, or n-sided, and what am I going to do now? I'm going to increase the number here. The n-sided xy, that's correct. There you go. As you can see, the size of my sweep is changing. And that is because the spline is instructing it to do so. So the spline can actually grow things. Aha. 1 second. There we go. When you're using a spline, be aware that although my sweep object has a certain profile, the thickness of the profile, which is taken into account, is this. And I did a mistake here. There we go. So now, the spline, although I'm not touching my actual original spline, the spline allows us to grow this. So we're using a procedural setup to create an animated spline or something like that, but it's fully procedural. And this happens because we are using the spline object. it has a lot of modes. One of the best is that you can use effectors. So because the MoSpline brings splines in the mograph context, now we can use an effector to affect the points of the spline. So as usual, I'm going to go and add a random effector, set the effector to turbulence, and press play. And I can add a delay effector, I can add whatever I want. So if your setup needs a spline within the mograph context, the MoSpline is going to be the object you're going to use to bring it in. Just like the fracture object is the object you're going to use to bring other objects in the mograph context. Oh, the other thing I'm going to show, any questions about this? Good. The other thing I'm going to talk about is the mograph shaders, and particularly the mograph shader. So let's do the following thing. As usual, I'm going to make my cube. I must have done this a million times. I can always have a preset. My scene starts up like this. But it's an easy way to burn some time, okay? Good. There we go. And what I want to do here is the following thing. Remember we can control our clones using indices and all sorts of other things. And one of the parameters we control is the color. So what I'm going to do, I'm going to go here and add an effector. And I'm going to add a step effector. The step effector applies the parameter from beginning to end, from 0 to 100%, each clone ID at a time. So what I'm going to do here is turn off the scaling and turn on the color. Now, this color, this is how it renders. If I want to use these color values as a texture, because as I told you guys yesterday, if I make this editable, you will see that the color is nothing more than the basic display color we see here. Okay, so undo a few times. I want to use these colors to do something else. So you create a material. Let's go to the color channel. Go to mograph color shader. And we can go by color or index ratio. If I go by color and drag this on here, what will happen is that this color, which now matches the display color, and it looks the same now, but what the good thing is that I can go and do something like a colorizer. So now I'm using that ramp from 0 to 100% to map it to a gradient. Okay, why is the default gradient this color? Does anyone know? Maxon, a German company, has a default gradient, the colors of the German flag. I've been using Cinema 4D close to 20 years. I found out about this maybe 3 months, 4 months ago. Yeah. I couldn't work. I'm Greek. I don't work out these things. Anyway, the good thing is that now I can use that index ratio to colorize this any way I want. So with the mograph shader, we're taking these display colors that mograph creates and assigns through effectors, this color mode, and we can bring them into our shading system. You can use it in alpha channels, you can use it anywhere you want. So if I put this mograph shader in my alpha channel, so here again, mograph, color shader, now you will see that these ones are more transparent than these ones. So I can use it in any context, and I can create multiple materials and apply them. And it has the two modes, the index mode and the color mode. So the color shader is absolutely fantastic for what you want to do. Now there's another one called the multi-shader. So let's double click. Let's create a multi-shader, mograph multi-shader. Now the multi-shader is somewhat similar So we are going to use the color brightness, but instead of creating a range of colors based from black to white based on what it's doing, we choose how many steps it's going to have. So in texture 1, I'm going to put a color, the color orange. On texture 2, I'm going to put a noise. On texture 3, I'm going to put an image. Yeah, there you go. And I'm going to use this on here. So now we have a distribution of those 3 materials based on the color index. And this way, we can use the gradient which is generated by the colorization based on our index number, because the step effector uses the index number, and propagate that data into a material that has 3 slots, and these 3 slots are going to be divided over our object. So essentially, bringing different parts of Cinema 4D together with mograph is a big part of creating complex and very interesting and highly procedural setups in Cinema 4D. For objects, it's the fracture object, not the Voronoi fracture, the fracture object. For splines, it's the mospline. For textures and materials, it's the mograph shader and a mograph multi-shader. So the last thing I'm going to do to close off my presentation is, let me show you something that a lot of people don't know. And that is the following thing. I'm not going to do that cube again. I'm just going to copy this one, okay? I'm going to just do this. We can use the new Voronoi fracture with a cloner. Okay, so it takes the cloner as a whole and it divides it down. But one thing we can do, if we delete the point generation, we can use the Voronoi fracture to fracture unconnected parts of geometry. So let's see if is this going to work? It is going to work. So it's good to ask to know what goes on. And let me try this. I'm going to press C, middle mouse button, press C again, right click, connect objects and delete. And although this is just one polygon object, this is one polygon object, okay? If you use this method, you can actually consolidate them. So in a certain degree, it can do something similar to the actual fracture object. So it brings all these within the mograph context. And let's see if this is going to work. To finalize my presentation, I'm going to create a floor, select them both, right-click, add a rigid body tag, make sure this is set to all, drop them, and yeah, I just broke them apart. So these examples show how we can exchange information between the different contexts within Cinema 4D. And just to make it absolutely clear, when we talk about context, is that different parts of the software use different types of data in order to manipulate the objects or the materials in the most efficient way. So sometimes 2 things that have 2 different representations in Cinema 4D need to be brought together to exchange the data through a very specific pipeline. And these tools, again, are the fracture object and the Voronoi fracture to bring any kind of geometry within the mograph context. We use the mospline object to bring splines, and we use the mograph shaders to bring colors and shading. So, do we have any questions? Because somewhere here, I think 55 minutes, I've managed to pull it this far. No questions? Okay, did anyone learn anything today? Oh, good. I'm very happy for that. Well, always remember, you can find me on Twitter at noseman.gr. Follow me for no other reason other to make me feel better about my followers increasing. And I'm going to post any of these files I've made here. I'm going to post the links within the next week, so you can go at a Dropbox and download them for all the 3 sessions. And yeah, if you have any questions, go on Twitter, ask them, and I Sometimes I even make tutorials about people requesting certain features. So, thank you very much for coming, and have a great show.